Welcome back. Today we're going to look at functions. So the purpose of a function is to make it so that you can break your code up into multiple pieces. And rather than writing everything as one big, long piece of code, what we'll start doing is making separate individual functions that will break up the problem we're trying to solve. And so a function is a complete block of code with a definite start and end point. And it will be given a name that we'll be able to use to execute this function multiple times throughout our program. In addition, functions have their own set of variables. So you can think of a function as a little mini program that you can call from within your larger program. Functions can be passed data variables and they can return data. So just similar to math functions, you basically have some inputs, the calculation is done with them, and then they have an output. And when we design our functions, we have this principle called the single responsibility principle, where we really just want our functions to do one thing and one thing only. We don't want our functions to do too much. So when you're defining a function, what you typically do is ask, what is it that we want this thing to do? And then in order to do that, what do we need to provide the function to provide its job? What types of inputs? And then what do we want that function to return? So the syntax for a function reflects that. We have a return type, which is what this function returns. And then we have a parameter list, which is the list of inputs that this function will use to do its calculations. This top line, the function prototype line, has the name of the function, a return type, and an input list. Notice that the input list is between parentheses. And we're going to see later that even if you have no parameters for this function, you will still provide the list with an open and closed parentheses. The function name is going to follow the same naming convention you've used for variables to come up with an identifier for it. And then the return type are the same return types you've used for your variables, int, double, floats, char, string, that type of thing. So how many tasks should you design a function to accomplish? One and only one, or as many as you need? Pause, think of the answer, and then hit continue. The answer is one and only one task. You don't want your functions to be too complex. In fact, the whole purpose of having functions is to break your code up into a series of simple steps. So by keeping our functions small and only doing one thing, we simplify the process of programming. There are several ways, therefore, of structuring our functions. And here in your book, you have 3 different functions, which we'll go over. So the basic format for writing a function is, and part of the syntax is, that the function name must follow the standard C++ naming conventions. It has to use upper or lowercase characters, or it can use the underscore and numbers, but it must always start with either an underscore or a character. There may be one return type. Functions only return one thing, and that return type is going to be in a type like integer, float, double, those types of things. If there's no return type, there's a special return type for that in functions called void. So even if you're not returning anything, you still have to have a return type declared. You're just going to declare the function as void. The argument list, the list in parentheses separated by commas, must have data type and names that look very similar to variable declarations. And you may pass in as many arguments as you like, or as few, either 0 or more arguments. If your argument list is empty, you still need the parentheses. They're just going to be an open and closed parentheses. So here's an example of the write hello function. And this function, the way it's been written is that it's a void return type and it's parameterless. So you can see we have open and closed parentheses. Even though we don't have any parameters, we still have to provide the parentheses. The parentheses are what tell the compiler that this is a function. Otherwise, if you didn't have that, it would think this is a variable declaration. And then following the function, we have a block of code. So the idea is that when we call this function, write hello, it will do what's in the block of code. And in this case, all it does is output some information to the screen. So no parentheses and nothing's returned with this function. Here we have a parameterless function that returns a value. And so we can see that this function also has no parameters. However, it does have a return type. So ask for age doesn't take any inputs, but it does provide an integer. And typically, this is the structure for an ask function because it's going to get input from the user through the keyboard, and then it's going to output that. Notice that the return value, the value that we're returning is age. Age is an int, and that matches the return type of the function. So whatever you have after the return statement has to be of the same type as the return value for the function. And in this case, this function declares a variable called age, which is an integer, asks the user how old they are, inputs that from the standard input into age, and then we have the cin.ignore because, of course, anytime you do a cin, it leaves the carriage return in the input buffer, and we have to clear that out, or we want to clear that out at the end of any function which does a cin. And then it returns that age as the return value for this function, or the output of this function. The next function is very similar to the last one. Again, this is a function that has 0 parameters. And it has a string return type instead of an int. So this function declares name. It uses a get line to get the name from the user and put it into the variable name. And then it returns name, and because name is a string, it is meeting the output of the type of this function. And so again, we have to make sure that whatever we return matches the return type of the function. In this case, it is a string, so that will work. Here we have another format of a function. In this case, this function doesn't return anything. It's declared as void, but it does take 2 parameters. And notice that the parameters look like variable declarations. They have a type and an identifier. And these parameters are going to be brought in, and then we just are outputting them. We're using them just like we would any variable inside of our block of code. And typically, if you have a function that takes inputs but is void, it doesn't return anything, this is really it's often a write type of function where you're outputting information to a screen or to a file or something. So how many return types can a function have? None, one, more than one, none, or one. So pause, think of the answer, and then hit continue. In this case, the answer is 1. Functions can only return one item. And if you look at the function, they only have a single return variable, so a return type. So they can only return one thing. If a function returns nothing, what do we use for the return type? Do you leave it blank, or do you use the keyword void? Pause, think of the answer, and continue. The answer is use the keyword void. Functions always need a return type, so if you're not returning anything, you use void. Let's look at, so next, we've defined our functions, but now how do we use them? How do we call them? And first, let's talk about how we describe this. So the terms calling function and called functions are often used referring to functions. And functions can call each other. So when one function accesses another function, it's said that function 1 calls function 2. And we also say that function 1 is the calling function and function 2 is the called function. In order to invoke or call a function, you'll need to have a statement that calls it. So the calling statement is the code located in a program where the function is to be used. And depending on the requirements for the function, the way your function calls look may be different. So let's take a look at the functions we use. So here we have main. In this case, main is the calling function. And all of these functions in here are the called functions. So if we look at this code, we have multiple functions being called. And the first one is write hello. Write hello is parameterless. And void. So you can see that in this case, we just put the function name. So we can see we have multiple functions in here that are being called. Write hello is a parameterless void function, and when we call that, all we do is we put the name of the function and open close parentheses. We still need the parentheses because this tells the compiler that we're calling a function as opposed to just doing something with a variable. And so in that case, a void function, a parameterless function, is fairly easy to call. Ask for name, on the other hand, is a function that that returns something. So if you have a return type other than void, your function, you must take the output of the function and use it some way. Typically, what you're going to be doing is assigning it into a variable. So we can see here we declared a variable in main called name, and we're assigning the output of this function into name. If you don't do this, it will still call the function. It's just that you'll lose whatever output this function has. So if it has a return type, you must assign that into something or use it somehow. Now, note that we've using the string, the name of this string is name here, but the names inside of main have nothing to do with the names used inside of your function. The function has its own memory space, and so what's declared in main inside of a function has nothing to do with what's declared inside of main. So name inside of main is getting the value that's output from ask for name. And since the type, you also note that the return type of ask for name was string, and therefore the variable we put its result into also has to be a string. Ask for age returned an int, and age, the variable which we're assigning the results into, is also an int. And then the write function, you'll see we're taking those two variables which we got the outputs of those two functions from. We're taking those two variables and we're passing them into the write function. And then the write function will then write these two variables. Note that these variables don't have to match the names of the parameters for the write function. They could be anything we wanted, but what the types of these parameters must match. So write takes a string and an int, and we are providing a string and an int to it so it can do its work. And again, since write is a void function, we're not doing any assignment into another variable because it's void. It's just like write hello is void. We don't have an assignment operator on the left like we do for ask for age and ask for name. So how do we write these functions? Every function must have a function prototype and a function declaration, and then a function definition and function body. And what that looks like is something like this. So if we have a function, we have a program here, and we want to write a function that's ask for name, say. And so we could write the function up here like this. And since we're using string input, probably need to include the string library. So here we've defined our function, and we've defined it above name. So in order, if we just define a function, note that if I run this, it doesn't do anything. In fact, we don't have anything happening in main here, so it's not going to do anything. We have to invoke the function or call the function. So to call the function, I just say ask for name. And if I did that, it would actually call the function, but we wouldn't, nothing would happen with this. It would get this string, but we're not doing anything with it. So often in main, you will be declaring a variable, and I'm going to make it a different variable just to show you that this has nothing to do with that one. But we're often calling our function and putting the results of that function into a variable like this with an assignment operation. So if it has a return type, we have to put it into an assignment operation. And just to display that we got something, you can see. So following it with debug, I'm going to put a breakpoint here and run and click, and then we'll go to debug, start debugging. And so here we see the execution pointer after we started debugging was at username. I'm going to then hit F10 and step over. And then I'm just going to keep stepping. Well, right now we're sitting over username. Now, when you're debugging a program with a function and you want to step into the function and see execution into the function, you need to use F11, step into. So I'm going to step into that function. And you can see now execution transferred from this line here into our function. I can then keep stepping over I can keep stepping over and execute each of the statements. So we saw please enter name shows up here now. We'll do the cin. And when we're done with the function, notice that when we're done, it came back to username. Right now, username is empty. But once we do one more step over, username will then get the results of this function, and we can see that Rob is now has been assigned from the function into username. And then when we step over one more time, the output happens, and that's how it's able to get the output. So we can see that this function got a name from the user, returned it as a string, we assigned it into this string called username, and then it was displayed. So this is one way we can define our function. And we have to put the function beforehand. Watch what happens if I place my function after main. If I try running the program like this with the function afterwards, I get a build error. And it says ask for name function not identified. So when I double click on this, it'll take me right to where the error is. And we can see it can't find it. And the reason is because when the compiler ran through the code, it started, the C++ is a single line or a single step processor. So it goes through line by line. When it gets to this function, it says, hey, I don't know what ask for name is because I haven't seen it yet. That's why we have to define our function beforehand. But for several reasons, we kind of don't want to do it that way. We actually do want to define our functions afterwards. One, aesthetically, it kind of makes more sense to see the overall program first. But what we can do is we can take the function prototype, the top part of the program, and we can put that at the beginning and then put a semicolon. And so this is how you're going to frequently write your functions. You're going to have a function prototype at the top, and you're going to have the actual function definition at the bottom. So I usually say that this is function declaration. And down here we have function definitions. And if you run it that way, then this program works just fine. And because we've declared the function ahead of time, we can then reference it. And the compiler will say, okay, I know there's going to be a function called ask for name. I know it's going to return for a string, so I can do my validation. Yes, this function type is the same as the thing I'm assigning it into. And then it will allow the definition to happen later. So every function must have a function prototype and declaration statement, which tells the compiler what the function name and its return type is before it gets used. And the function definition and body can happen after main. So when you're writing a function, concentrate on one function at a time. You know, when you look at the overall program, you can use some pseudocode to write out what your program needs to do to solve the problem, but then take each of those elements and write a function for it. And then when you're working on that function, just concentrate on that one little block of code. This function is its own little mini program. It's got its own memory space, and it takes inputs and then returns an output. And within the space of these curly braces, we only worry about what came in and what's going out, and we don't worry about anything else in the program. So one way of writing your program is write the function, the prototype. And then you can see if it can be called, then write the function. Here, let's say we have an example here where we want to write a program for a C++ hotel, and there's different costs for different types of rooms. If there's a view of the beach, it costs $99.95. If it's a view of the pool, it costs $79.95. A view of the parking lot costs $59.95. And those are the rates for a single room with one person. Each additional person is $10 per night. So those are the business rules we want to write a program for. When we're figuring out the structure for our program, it might look like this. Here we have main, and we're going to have a bunch of function calls in here. But the functions we're using are like this. So we have how many people, how many nights, calc cost. And you can see each of these we're figuring out that, okay, for how many people, it's going to be an ask function. So there's no parameters, but there's a return type. Same thing for how many nights. And then we may have this calculate function. And a calculate function may take some parameters in and then has a return type because it's going to use those parameters to do some calculation and return a value. And then we have this write cost summary, which is void. It's an output function where you get some inputs and then it writes it to the screen. So you can kind of block out your code this way. Notice we have the function definitions down below. There's a little comment up here that we need to put our includes up there, or that we need to put our declarations and prototypes up here later on. But this allows us to just kind of think about how to structure our program. And as we said, before a function is called, the calling function must know about the called function. So we have to have that function prototype. This is the function prototype. Have to be declared above the function where it's called. The other advantage of this structure is if we have multiple functions that may be calling each other, if we put all the prototypes at the top, we don't have to worry what order we define our functions. This will take care of that. And the form for your function prototype is the same as the top part of your function. The only difference is that you don't put the function body and you have a semicolon. So you can see here, this looks exactly the same as this, except it doesn't have the function body. It just has a semicolon. Now, as a matter of practice, what I recommend is you never alter your function prototypes directly. That what you do is you always alter your function definition and then copy and paste your function, the top part of your function to the function prototype. This will help ensure that these do not become disconnected. One of the pitfalls of C# is that if your function prototypes are different than your function definitions, your code won't work. So here's some examples of the prototypes that we'd use for that C++ hotel example. You can see there's write greeting, how many nights. Here's one which takes parameters and returns a value. Here's one that takes values and returns void. And you'll notice that they're just the top part of the function with a semicolon and no block of code after it. So a function must have a function prototype declared before it can be called. True or false? Pause, think of the answer, and hit continue. The answer is true. Yes, the function must have the prototype declared before it can be called. If it doesn't, if the whole definition isn't before the function that calls it, or if the prototype hasn't been provided before the function calls it, you'll get a syntax error. If a function is defined before the code that calls it, a separate function prototype is not needed. True or false? Pause, think of the answer, and hit continue. It's true. You could declare your function like this, where we take the function and we put it before it, and then we wouldn't have to do this function prototype. And some languages are structured to do it primarily that way. For C++, this is not a good practice. And the reason is that if you have multiple functions up here, they may call each other, and you may get in you have to worry about what order they're in. If we put all of our function prototypes before main and we put all of our functions after it, if we declare all of our function prototypes at the top of the program, we don't have to worry then which order these functions show up in. Since everything's been declared at the top, they can call each other in any order. The return statement serves three purposes in C++. One, it's required when you're returning a value from a function. So if any functions that are not void have to have a return function. Second, the return statement caused the program to exit controls. So as soon as a function, a program encounters a return statement, it exits the function. And then an expression may be evaluated within the return function in order to return the value that you want. So, here we have the return statement for the calc cost function, and we see that it's a return, and then we have a variable which will have to match the type of the function. So total cost, I think, was a float or a double, and that's probably the type of the function. You could also make that return do the last calculation in a calculate function, and basically what you do is you say return, and the expression to the right of the return value must evaluate to something that is the same type as the return type of the function. And so it's just going to do this calculation, and whatever this calculation is what's going to be returned. If your function is void, it doesn't have to have a return statement. All that will happen is it'll keep executing. When it gets to the last curly brace, it'll automatically return. So you don't have, with a void function, you don't have to have a return. So the purpose of the return statement is to do which of the following: return a value, cause the program control to exit, provide capability to evaluate an expression and return that value as the result, or all of the above. Pause, think of the answer, and hit continue. The answer is all of the above. A return statement can do all three of these things. So next, please complete the functions demo. And that concludes this presentation. Thank you very much.